Hi, I'm Miss Ginsburg with KnowAtom, and today we're going to be reading Communication Technology. This is a lab manual in Unit 9. Section 1, the day the internet went down. A 15-hour internet outage. For about 15 hours in February 2015, parts of Arizona experienced an internet outage. During this time, computers couldn't get online. Emergency 911 systems were disrupted. This forced emergency responders to use handheld radios and alternate phone numbers. Businesses couldn't process credit card transactions. ATMs couldn't dispense cash. The problem was first reported around noon on a Wednesday. It wasn't fully resolved until 3 a.m. the following morning. The internet service provider for that area said that vandals had sliced through a fiber optic cable. This cable connects cell phones, TVs, and internet providers with the users of those services. Internet communication system. The internet outage showed how dependent modern society is on the internet. There are currently more than 1 billion websites. Every day, users send about 269 billion emails and 500 million tweets. They upload 576,000 hours of videos to YouTube. The internet is a communication system because it is a group of interacting components that function together to transmit or exchange information between people and/or machines. Parts of a communication system. All communication systems have a source. The source is where information is sent from. Any object or person generating a message is a source. Whenever you create an email or text message or speak into the phone, you are the source. You input information into the system. Many communication systems also include an encoder. An encoder is a device that converts information into a format or code so that it can be easily and/or securely transmitted. A phone's microphone mouthpiece is an encoder. It converts the sound of your voice into signals that can be sent through the system. Similarly, your computer encodes messages. It turns keyboard strokes into programmed language. Some encoders also encrypt messages. Encryption is the process of encoding messages so that only the intended recipient can read them. Many email services offer the option of encrypting your messages so you can send them securely. The desire to encode information has been around for centuries. People have always wanted ways to create messages that would be kept secret. Around 400 BC, the Greek Spartans came up with a simple way to send encrypted messages between military commanders. One commander would take a tapered baton and wrap a strip of parchment or leather around the baton. The message would be written lengthwise across the baton. One letter went on each revolution of the strip. The strip with the message would then be unwrapped. Once unwrapped, the letters of the message appear scrambled. This allows the parchment or leather to travel to another military commander. Even if it fell into the enemy's hands, the enemy could not read or understand it. When the second commander received the parchment, he would decode it. Decoders convert coded communication into a form that can be understood. Decoders may translate code into human language. They may also decrypt an encrypted signal. The commander would need another baton that was the exact same shape and size as the original one. When rewrapped around the second baton, the original message would reappear. Storage, transmission, and receiving. Sometimes information is stored. Storage is a means of holding information for future use. A modern type of data storage is called the cloud. The cloud stores information in remote computers connected to the internet. It can be retrieved anywhere. Retrieval is the accessing of information that is stored. Another form of retrieval occurs when a software application pulls email from an online server or accesses information stored on a hard drive. Using internet to communicate. Communication systems also include a transmitter and a receiver. A transmitter is a device that sends information signals through a channel, air, wires, optical fibers, etc. Transmitters often have an encoder. A receiver is a device that captures incoming signals. Receivers often have a decoder. Many technologies send and receive information using different frequencies or wavelengths of light. In Arizona, cell phones, computers, and landlines were knocked out of service because the cables that connected the transmitters and receivers of many communication systems was cut. This cable was a fiber optic cable. Fiber optic cables transmit light signals from one place to another. A cut cable meant that information couldn't be transmitted from the source to the destination. The destination is the final place where information is sent in a communication system. It is the output of information. Benefits and drawbacks of the Internet. The Internet is the ultimate communication technology. It allows people around the world to communicate cheaply and quickly. However, as the cut cable in Arizona showed, there are some drawbacks. Fast and reliable Internet depends on the infrastructure to connect phone and Internet companies with the people who use these services. Many rural areas currently don't have that infrastructure in place. Other forms of communication. In rural areas, print, audio, and visual technologies are often more reliable. Print includes newspapers and magazines. These printed forms of communication can only be accessed when they are physically in someone's hands. Today, many people can read newspapers and magazines online, but this depends on Internet reliability. Radios are a reliable source of information in rural areas where the Internet may be spotty. Radios use radio waves to receive information. A radio station uses a radio tower that transmits a certain frequency of radio wave across a wide distance to broadcast music, weather reports, news, and other kinds of information. The limitation to radio communication is that only those radios within the range of the waves sent by the radio station and tuned to the frequency will receive the sounds that are being broadcast. This form of communication is only one way. In other words, the radio station can broadcast information, but it doesn't receive information from radios. In contrast, the Internet has the ability to be two-way communication. People can communicate back and forth with one another very rapidly. Section 2. Communicating with radio. A radio broadcast. When Emily Ross was a college student, she volunteered as a DJ at a college radio station. Every Monday from 3 p.m. to 5 p.m., she took to the airways. She would broadcast a wide range of musical styles from the station. Radio stations are part of a communication system that can send information across a wide distance. This information includes songs, breaking news, and weather reports. As a DJ, Emily was the source. She sent information to listeners to the station. When Emily spoke into a microphone, the microphone encoded the sound of her voice into signals that can be transmitted. Radio waves. Radio stations transmit sounds because they send out radio waves. Radio waves are a form of light energy. There are different types of light, and the type of light energy depends on the amount of energy in the different waves. Scientists organize the different wavelengths of light on electromagnetic spectra. The range of light waves that humans can see is called visible light. It is in the middle of this spectrum. Radio waves, which are sent out by radio stations and captured by a radio, have the lowest energy. Microwaves are used in appliances to heat up your food. They are also used in satellites for communication and navigation. X-rays are used at the dentist to capture images of teeth and at the airport to see through bags. How radio stations send information. All radio stations have a radio tower. This tower transmits a certain frequency of radio wave across a wide distance. Radios within range of the waves are radios within range of the waves and are tuned into the frequency will play the sounds that are being broadcasted. A radio is a device that transmits and or receives radio waves. Once a radio picks up a radio wave, it converts the information into electrical signals. Those signals are then decoded by a speaker. A speaker is a device that uses magnetism to transform electrical energy into sound energy. Speakers are decoders because they convert electrical signals, which we cannot hear, into sound waves, which we can hear. Radios, televisions, cell phones, and headphones all use speakers. How magnets work. Understanding how speakers work, begin with the basic rules of magnetism. Magnets are objects that produce a magnetic field. A magnetic field is the invisible area around a magnet that attracts or repels other magnets and magnet materials such as iron. To repel means to push away. To attract means to pull toward. All magnets have a north pole and a south pole. The north pole of one magnet always attracts the south pole of another. However, two north poles will always repel each other. Two south poles will also repel each other. One of the reasons that magnets are so useful is that they can attract or repel other magnets or magnetic materials without touching them. Whenever a magnet or a magnetic material is within another magnet's magnetic field, the field exerts a force that either attracts or repels the magnet or magnetic material. Magnetism and energy. Imagine that you push two repelling magnets towards each other. You have to use energy to move them together. As you push the repelling magnets together, you apply a force to the system that transfers the energy from your hands into the system. In other words, your pushing force provides an input of kinetic energy into the system. That input of kinetic energy is stored in the system as potential energy. You can see evidence of this potential energy when you let go of the two repelling magnets. They will move apart from one another. The potential energy stored in the system has been changed back into kinetic energy. If you change the distance between the interacting magnets, you change how much energy is transferred into the system. For example, the closer you push two repelling magnets together, the more energy you need to use. This means more energy is transferred into and stored within the system. This will cause the magnets to move farther apart when you release them. Conservation of energy. In a perfect system, the total amount of energy is always conserved as it changes from one form to another. In other words, however much potential energy the system of interacting magnets has, that same amount of energy will change into kinetic energy as the magnets are released and moved away from one another. However, in the real world, some of that energy is transferred out of the system. When energy is transferred, it moves into or out of an object or system. For example, if the magnets move across the ground, friction will transfer some of the energy out of the system. Speakers work by applying the rules of magnetism. Speakers have two kinds of magnets, an electromagnet and a permanent magnet. Electromagnets are tightly wound coils of wire that produce a magnetic field when electricity passes through the wire. They are useful in various technologies because the magnet can be turned off and on. This is different from permanent magnets, which stay magnetized without electricity. Electromagnets become magnetized when electricity moves through the wire. Electricity is the flow of electrons through a conductor. Because electromagnets are made with electricity, they can be demagnetized when the electricity is turned off. This is possible because electromagnets form a circuit. A circuit is the circular path that electrons travel in a negative to positive direction. Parts of a circuit. All circuits have the same basic parts. All circuits have an energy source such as a battery. The battery has stored chemical energy that converts to electrical energy, which is the energy of electrically charged particles. The battery's energy provides the input of force that pushes the electrons in the conductive material through the circuit. Circuits also have wires. Wires are the path that electrons travel in the circuit. The wires in a circuit are attached to an object that could convert electrical energy to do work. All circuits must include something that can do work. Without this part, the electricity will cause danger by overheating the circuit. This is called a short circuit. Finally, most circuits have switches. The switch opens and closes the circuit. Electrons flow when a circuit is closed. This is on. A closed circuit will cause the light bulb to light up. Electrons cannot flow when a circuit is open. This is off. No work can be done in an open circuit. How speakers use magnets. The way a circuit is put together affects the amount of electric current that can do work. Current is a measure of the rate that electric charge passes through a point in an electric circuit over time. The amount of work that can be done increases as current increases. For example, a fast current will cause a light bulb to shine more brightly than a slow current. This is because more electrons reach the bulb in the same amount of time. The ampere is a unit of measure of electric current. Electric current produces a magnetic field. As electrons in a conductor move in the same direction as one another, their movement produces a magnetic field around the wire conductor. The magnetic field around a straight wire is not very strong. However, if the wire is wrapped in a coil, the fields produced in each turn of the coil add up to create a stronger magnetic field. This is the idea behind an electromagnet. A tightly coiled wire produces a magnetic field when electricity passes through the wire. The electromagnet becomes magnetized when the circuit is closed. It becomes demagnetized when the circuit is open. There are several ways to make an electromagnet stronger. One way is to increase the coils an electromagnet has so that it produces a stronger magnetic field. Another way is to increase the current that moves through the circuit. Speakers turn electricity into sound. The electromagnet in a speaker is attached to a cone that is made of fabric, plastic, paper, or lightweight metal. The purpose of the cone is to push air so that it vibrates. We hear these vibrations as sound. Sound is energy that is carried in waves of vibrating molecules. As forces transfer energy through a system, they disturb molecules at rest, causing them to vibrate. Vibrating molecules bump into the molecules closest to them. This passes on the energy and makes them vibrate too. Then those molecules bump into more particles and so on. The vibrations travel out in all directions. Molecules stop vibrating once they have passed on the energy. These patterns of vibrating molecules as sound moves through a medium are sound waves. Magnets in a speaker. On the other side of the electromagnet is a permanent magnet. When the speaker is connected to a receiver, electricity flows through the wires. If the electromagnet in a speaker is positioned so that its north pole is near the north pole of the permanent magnet, the two magnets will repel each other and be attracted to each other's south pole. These attracting and repelling forces cause the coil to move back and forth, pulling and pushing the speaker cone. As the cone moves back and forth, it produces vibrations. The volume of a speaker can be changed. A stronger electromagnet will cause the cone to move more, generating a louder noise. This is similar to banging a drum harder, making the drum membrane vibrate more so it produces a louder sound. The size of the cone will also change how much air is vibrating, which will affect the speaker's sound. I learned a lot reading communication technology, and I hope you did too. I'll see you tomorrow with another book. Bye!